So hey guys, welcome to channel. So in this video we are going to see what is binary right shift. So let's start. So the binary right shift is an operator that moves all the bits of a number to right by a specified number of positions. So basically binary right shift is an operator moves the number of bits to the right hand side, okay, by the number that we have specified. So each shift to the right divides the number by 2. Okay, so as we shift the bit to the right side, it is same as we divide the number by 2. We will see its example further. Let's see how the binary right shift works. So first point is shift right. That means moves all the bits to the right by a given number of positions. So basically, let's suppose there is a number 5 and we have to move its bits to the right hand side by 1. Okay, so the binary representation of 5 is 101 and we have to move the bit to the right side by 1. So after moving the bits to the right side, the output that we will get is 10. Okay, so that means 2 in decimal format. So ultimately the number has been gets divided. The number that we have taken is 5 and the answer that we get is 10. So this is example of the binary shift. So the next point is handle leftmost bits. Okay, so for positive numbers, zeros are added on the left side. Okay, if the number is positive, the zeros are added to the left side, and for a negative numbers, the behavior depends on the type of right shift. Okay, so whether it is arithmetic or a logical operation, as per the behavior, the bits are assigned. Next point is divide by powers of 2. So each right shift divides the number by 2 raised to n. Okay, where n is a number of shifts. So let's see the syntax for the binary right shift. So A right shift B, okay, where A is the integer value that we have to shift it and B specifies how many positions to shift the bits. Okay, so let's see the example. We have to shift the 8 to the right hand side by 2. As you can see that this is the symbol for the binary right shift. Binary representation of the 8 is 1 0 0 0 and rest of the will fill with zeros. Okay, we have to shift the 2 bits to the right side. Okay, so this 0 will come here, then 0, then 0 0. Okay, so this two number will get discarded and the remaining spaces are filled with zeros. So 0 0. Okay. The decimal representation of 10 is 2. Okay. Now we have to take the second example. Here we have to shift the 8 to the right side by 1. Okay. The binary representation of 8 is 1 0 0 0. Okay. And we have to shift its bits to right side, so that means this 0 will come here, this 0 will come here, 1, and rest of the elements with zeros. So that means this 0 will also come here, 0 0. Okay. And this 0 will be gets discarded and whatever the remaining spaces are filled with zeros, so this number will be get 0. Okay, so the output that I have get is 100. Okay, now representation of 100 is 4 in decimal. Okay, let's see the rules for binary right shift operator. So A right shift B is equal to A divided by 2 raised to B. Okay, so let's say 8 right shift 2. Okay, here 8 divided by 2 raised to 2. Okay, so 8 upon 4, and it answer we will get is 2 in decimal. Okay, now let's take another example. 8 right shift 1. Okay, so the answer will be 8 divided by 2 raised to 1. Okay, now if we do divide 2 4, okay, so the answer that we will get is 4 in decimal. Okay, so this is all about the binary right shift operator. Thank you for watching this video.